Live. Okay, for people joining this live stream, we are doing some design reviews for the upcoming version of Wolfram language. And this morning, we are starting off with some machine learning capabilities. So let's get down to business. What's first?
All right, well, we could go in the order of the notebook, huh?
That would be what I would assume.
It's an order not that bad. As good as any.
Okay, feature extractor. So
no, this one has no documentation. This is just going to be, indeed, generic expression features are going to be extracted from generic expression, but there won't be a named feature extractor. So this is something that, won't be documented.
So I'm sorry, I don't understand this. I mean, so a feature extractor, if I just give a generic expression, we think we have a way of picking out features relevant for a neural net for that. Is that right? Is that what you're saying?
Yes. And any machine learning subsequent task. And
well, I understand, but so that seems a challenging thing because an expression can represent absolutely anything. And what are the important features seems hard to know.
Yes.
So what are we doing there?
So, the idea is to extract sequences from the tree, including several sequences. There may be some more complex stuff. I haven't finished the development of that. But for sure, in terms of design, it's not something that we can, it's going to be part of the numeric.
Okay, but to me, look, there's a lot of arbitrariness in the way this is done. And to me, we've got to be able to name the feature extractor. So this is, the version 1 tree extractor, or maybe not version 1, but some name that characterizes what this particular tree, what this particular expression.
I guess, yes, it's true. We could do that.
We need to do that. So I think what we should do is say, if it has a particular strategy, try and succinctly name the strategy and call it the blah, 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 feature extractor for expressions. Yeah, I mean, and in terms of what strategies are right, I mean, it really depends so much on what the expressions mean. I mean, if the expression represents a piece of graphics, then obviously that's a completely different feature extractor from an expression representing a program.
Does the feature extractor actually, I mean, I assume an audio is also an expression, but we have dedicated audio feature extractors.
Exactly. So it's for expressions that are not recognized as known feature type.
Right. So it could be almost, it could be.
I mean, graphic would already be handled by images.
Okay.
You would rasterize and then.
All right. But it's a none of the above expression feature extractor. Okay.
Yes.
But can we characterize what are some examples of none of the above expressions? I mean, in a sense, it's going to be temporary because.
Can you describe what it does again, Etienne? Because it sounds to me like it views it as a tree. It's sort of a tree-oriented view of expressions.
Each expression is a tree. So one thing, I mean, it's not finished now.
But without sort of semantic meaning, basically.
So you can traverse this tree in a given direction and produce a long sequence, or you can have several sequences where like one way is to do random walk in the tree. I mean, going down randomly, and this produces one sequence, and you do it again, you have another sequence. That's some ways to extract features.
Okay, but hold on. So first point is, we have the new trees framework coming, and we have traversal order, a bunch of traversal order control for that. In fact, we're planning general traversal order control even for things like map. But if what you're doing is serializing a tree effectively, then you've got different strategies, depth first, breadth first, everything in between. Right? And you're basically describing this, it sounds like, as a thing like that. You're sequencifying a tree.
Yes.
Okay.
Yes. And it's a last resort. It's because right now, when there's a feature that we don't understand the type, we just say it's nominal. So it's like super dumb. So it's a next step. So it's true we could already have a named feature extractor that does that, but I don't know. I thought it was more of an internal thing that we try to improve. And yeah, and as you say, little by little, some type we did not understand before, we will understand them and treat them separately. Yeah, so I don't think that's a big deal. Like, I mean, we could have a name thing already, but it's typically it's for very nested expression, like sequence.
Okay, but I think you can't. No, I mean, so this is a serialization of a tree structure. Okay, so then what we've got to do is I mean, I think it should have some traversal order option or something, but I think you should ask, I mean, the people who are working on trees, namely Ian and so on, I think we should take whatever they're doing as ways of serializing trees and offer those things. Because they also deal with, you know, heads, and do you go into the head? How deeply do you nest inside the head, et cetera, et cetera, et cetera? Do you pick the head before you pick the arguments? All those kinds of things. Am I making sense?
Yeah, yeah. Usually serializing is a bit different though, because it's only about keeping information. What there we want to have, like, you know, most of the meaning preserved.
Well, I know, but we don't, since we don't know what the meaning is, it's tough to know how to preserve it.
It's yeah, but
now, I mean, if there's a way to take a tree and, well, okay, so look, in the end, it's got to be turned into a neural net friendly, you know, neural net friendly food, which is essentially arrays.
Yes.
Okay, so how do you model a tree with arrays? Well, you know, there are a variety of ways to do it. You can write it out in essentially full form with brackets. I mean, you could write out something that has those kinds of things. You could write out, I mean, is that what, in what form will it be fed to the neural net? Is it purely an array or is it something else?
I think it's going to be a sequence of vectors.
Okay, but then, so look, what we need to do is inventory what those possible, you know, what could be in those vectors. Right, because like for example, if we have composite heads and then arguments, like, yeah, I mean, this seems like a.
I don't think it's something we should document now. This is something we're going to experiment on. That's something we're going to improve. I'm going to do a first version, put some ideas. It's going to improve
okay, fine.
later.
But then, so what's the discussion here? I mean, this is this something? Can we put this feature extractor into the neural net repository? Can we put several choices of it into the neural net repository?
Repository, I don't know.
That's what I'm asking. I mean, can't we? Isn't this a modular thing that could be put in the repository?
So it will be part of feature extra. If we want to have the user control this, it will be in feature extraction and in the encoder. So that's related to the second item, and then there could be ways to control the method, yes. But for now, I don't think that's something we should discuss much. It's going to be some internal thing. It's going to be something we.
So I don't understand. I don't understand that somebody gives us an expression which yes. You know, the pieces which we understand, images, audio,
yes,
you know, blah blah blah. We understand all that stuff. Okay. Yeah. There's wrapping or there's sub pieces.
Yeah.
General expressions that we do not understand.
Yeah. They will see which expression we don't understand. So when you do the model, then you can get with information and even write on the visualization of the model, it shows the interpretation of features. So it will say image, text, you know, nominal, blah, 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 blah. So they might see something, expression. And I'll say, okay, well, this hasn't been understood as a classic type. And then it try to do something on this expression. That's the way it works currently. So we have kind of the feature types that are documented, and which user can control as well with the feature type option. So there will be a new feature type which will be expression.
Right.
So actually, yeah, this will be documented. There will be a new feature type expression. Yeah.
Well, I'm sorry. So okay. Just a minute. Okay. So Ethan is commenting that he hopes that UMAP will be a feature extraction method.
Mm-hmm. It's on our calendar. It's on our calendar, on our item list of things to do. But not for this version. Next one, pretty sure it's going to be in.
So there are various suggestions on the live stream about dealing with hierarchical, dealing with HTML and things like this. Yeah. I mean, I don't think, that's what this is relevant for, right? But I mean, that's not our type of expression. So that's, again, yet a different kind of thing. Like HTML, there are presumably pieces of HTML that one cares. I mean, I don't even know whether formatted text is something for which there is a good feature extractor. Is there?
What text?
Formatted text. Text which has, headings and this and that and the other. What are the feature extractors for that?
Yeah, no, I don't think we will understand them.
No, I understand we don't, but
we could use a box structure and send that to expression feature extractor.
We could, yes, we could.
As a zero level approximation.
Well, I know, but a notebook, for example, what is the feature extractor for a notebook? I don't think we've thought about this properly, and
well, first maybe we need some applications for the. You want to classify the notebook content, for example, the topic.
I know. Yes, that's a good question, and that's why I'm also concerned about this general expression thing, because I think without knowing anything, it's tough to know, to go anywhere. But I mean, we're not. What does it do right now with general expressions?
It assumes that they are nominal values, A, B, C.
I see. So it doesn't go inside at all.
No, not at all. So the idea was just the next step. Like, it's a small project, it's first on the agenda.
Fair enough.
Like,
fair enough. Okay, so all right, so we're just trying to go inside it all, and then a separate project is to study. It's a good topic for be a good topic for summer school projects and things like that, to study different expression encoders.
Yeah, definitely.
I'm going to add that to my list here. Hold on one second. Since I don't think we have a project manager in this meeting, is that correct? Let's see. Okay. All right, onward. Okay. What's the next thing here?
It's
classify, predict.
Feature extraction, just before, feature extraction as net encoder. So now it's documented, and Jerome did it actually, he implemented it. You can use a feature extractor function inside the network.
That's nice.
At the place of the to encoder. And also you can learn a feature extractor just before the training. When you do net train of a net, and if in place of the net encoder you put a feature extraction method, like standardize, or BP encode, whatever. It will learn this extractor and then include it in the network. So there's the documentation page if you want to look. It's just the feature extractor. I forgot how it's called, feature extract.
Okay, do we have Jerome here?
No, but check net encoder.
Let's
net
get
encoder.
Jerome, please.
Just if you look at net encoder, it's going to be in.
Okay, we got to not do these meetings without the people who wrote the code. Okay.
That's true. Yeah.
Okay, which one am I looking at?
Net encoder. Then you can see that it's a new, and then you can see the feature extractor 12.3. So it's a new type of net encoder which use feature extraction underneath.
Okay, so wait a minute. So in that case, how are you giving the feature extractor? You've got to give the name of the feature extractor, right?
Yes. So,
where do you go do that?
So if you
click, yeah.
What should I do?
Click feature extractor, the string. It will open the page dedicated to this specific net encoder. And you can say net encoder feature extractor, comma F, and you put the feature extractor function. Or you can just put feature extractor by itself, and it will figure it out how to extract features. Or you put the method as a second argument of the list. And we also added, as kind of syntactic sugar, you can also just directly put a feature extractor function
inside the network
encoder thing. Yeah, exactly. You just do.
Where did you document that?
NetGraph, for example.
Okay, looks nice. I don't really understand this encoder automatically learned during that training. Explain.
So this, it will. So you don't give a feature extractor function, right? So it just transforms to, as you say, something that can be understood by a neural network.
Yeah, but what's the raw material? What raw neural net is it training then?
So this you include inside a network, right?
Yes.
The net encoder goes inside a network, and this network goes inside net train. And so the data that is inside net train is going to be used by the feature to learn a feature extractor.
By the way, I think Jerome is here, so maybe I don't quite understand that. We've got some network. Usually there's an appendage, which is the feature extractor. But here you're saying there's no appendage. Is that correct?
There is a...
Wait, what layers? Are there weights that are being learnt in this feature extractor? Okay, so of weights of what?
For example, the standardization. It depends on your data.
I understand, but I'm asking the question. If you put in a net, this feature extractor net encoder piece, okay, in a network, what additional weights are what new degrees of freedom are there being added that are then going to be trained?
Okay, it's a separate training. So it's not part of the network. So it's when you do net train, the first thing it does, it learns the feature extractor completely independently of the rest.
And what controls are there on that? Like how many rounds of training does it do? What is it,
It does not, because it uses feature extraction, which is just, it's just.
I think maybe the easiest thing to say is that this is completely equivalent as doing feature extraction on your data set and then taking the result and using it in the network.
Exactly. Okay, fine.
So this is in one go, basically. Instead of you doing two steps, you do it in one step.
What about the options to feature extraction? How do they get fed through?
Through this method, the third line of usage, third use line, feature extractor method. So you can specify standardized vector indicator make.
Okay, well, what about the options?
There's no options for feature extraction.
Is that right? It just it has no.
Wait. Okay, it depends what we talk about. There is a plan to have an option related to the extraction method, which is not there yet. But it's true that there is.
There are all kinds of random seeding is an option, all kinds of random
exactly,
options.
Yeah, there is this. Yes. There is this. And this, it's true, we have no control over.
Okay.
Well, this is also more of a convenience than the main way to do that. Yeah, I mean,
well,
you can always do it separately and set whatever you want.
I understand that, but I'm asking the question. I mean, so what are we adding here? So it's the ability to put a feature extraction output inside a network, or what?
Yes, that's the main thing. Your feature extractor function, you can put it in your network. That's the main thing. And
well, okay, so that's the primary thing to document then, because it seems like these cheap approaches may be fine until they're not fine, and then it has to be said in this documentation that you have to go to this full form if you need to.
Yeah.
Right.
Yeah.
Yeah, we could clarify. It is the first usage to, I mean, the one that we advertise the most.
Okay.
But yeah,
right,
we could be more specific.
We're only on item 2. We've got a lot of items to go through.
Yeah.
Let's.
So, yeah, classify, predict, SHAP feature explanation. Something we talked already. You can open classifier function. That would be one way to see it. Then it's copy pasted in other places. So basically, it's a new property of the classifier function. You see these SHAP values, 12.3 plus.
Yep.
And we decided, originally we had 2 properties, SHAP values and interventional SHAP values. And then we decided to have only one, and you can, through missing imputation, missing value synthesis, which we should talk right after. Very, very connected.
Okay, so what does it basically return?
So this returns something that has the same shape as your input data, your input examples, but instead of the variable values, you have the feature Shapley. You have the Shapley values.
So wait a minute, it's the same size as all of your examples, or the same size as one of your examples?
It's independent for each example. So let's say you just give one example to your classifier to return something that has the same shape, but instead you have the Shapley value inside.
Wait a second. This is, when you say example, the thing is trained, and now for this particular instance,
yes,
it's telling you
exactly. It gives you the contribution of each feature to the result.
Well, this is a completely obscure piece of documentation. This is an utterly obscure piece of documentation. What this should say is, okay, so most of these things are giving you, in most cases, probabilities in the classifier function will return, some list of possible classified things, and in each case, their probability. What this is returning, if I'm trying to understand it, is, oh, I see. For each, but you shouldn't say example. That's not what we're calling them.
Yeah, no, okay. It was a copy paste from classifier measurements where it made sense in that context. Yeah, you should remove, I will remove for each example. It's Shapley additive feature explanations, yeah.
Right.
Yeah. We first did it for classifier measurements.
Right, and obviously you've got to give some examples here in
of course.
In the documentation. But then, and so what's the normalization of these values?
So they sum, let's say for predict, the sum of all these values are the difference between the mean value in the training set and the prediction. To be simple, they sum to the prediction for predict. And for classify, it's something different.
But so for classify, you've got a dog, picture of a dog, and it's got, so let me understand what this does for an image, for example. Okay, so for an image, do you get an image for the SHAP values?
No, it will be an array. We won't support image for the first version, but it will be an array that has a size. And we talked about it. At first, we wanted to return an image, and then realized it was kind of crazy for various reasons. So it's going to be an array, the same size, an internal array that is in the image, and give all the SHAP values for every pixels, basically.
Okay, so I can just say image of that, and I will convert it to an image.
Yes.
And are the SHAP values always positive or not?
No, can be negative as well. can be negative. That's something we already designed together. Like was kind of set.
All right.
Yeah, we document a little bit better, but the missing thing was missing value synthesis. That's a new option. That's we should definitely talk about.
Okay, it's in here. I don't see it here.
Actually, you can click it. You can click it here.
I don't see it here. Where is it?
SHAP values, assess the contribution, like on 12.3. You can say missing value synthesis.
I'm sorry, where? What? Oh, there.
Yeah, there.
But I don't understand. Well, why isn't that documented in the options here?
I have to put it. Yeah, we didn't put it. We didn't put it, and
yeah, is somebody taking notes here? No. Okay. We're going to need in these meetings going forward, Roger. We're going to need somebody who's able to take notes. Roger.
Yeah, but don't you usually have someone that from?
No, but you specifically don't have project managers, so we haven't brought project managers in here. So we're going to have to insert.
But in previous meetings, you've had someone that then sends out notes. Is that changed?
Well, but they've been the project manager for the project, but you don't have project managers for your projects.
So where can I get someone that takes notes?
I don't know.
I don't have.
Why don't you ask? Why don't you ask? Why don't you ask Danielle or Sushma?
Isn't Devin doing something for machine learning?
Oh, but there's Devin, of course, Devin. What am I thinking? Devin,
okay, but there's got to be somebody for each of these meetings. Okay, so
yeah.
Okay.
So yeah, Devin should be there.
Well, maybe he should come now. Okay, I'll ask. Okay. P. Winkler on our live stream is commenting that classify with tree methods is not working for batch prediction. Batch prediction is useful because it's faster. Is this going to be fixed?
What doesn't work with batch precision?
It says classify with tree methods.
Oh, surprised. I think it works by batch. Huh? I think it's parallelized, but I should double check.
Who would be the relevant person for that?
It's me.
Okay.
Me, Timothée, Big New. I think he worked on that as well.
Okay.
So we should double check, but I think it's like for random forest and stuff. It's definitely parallelized.
Okay. All right. So if that's not working, it's a bug. Okay. Missing value synthesis.
Okay. Option to control how to impute missing value in everywhere.
Mm-hmm.
Classify, predict, everywhere.
Okay, so what we've called the main function that does this is, what is it called now?
Synthesize missing values.
Okay.
You can see it actually on the first paragraph.
Okay. So what is this defining? This is defining the method for missing value synthesis?
Yes. I mean, method and strategy, as we call it. So you can either control, so I mean, several things you can do. You can put a learn distribution in it, something that you trained separately. Then you can also put the method of learn distribution, like multinormal or kernel density estimation. And also there's another type of things that we call strategy, which is once you have this distribution, do you find the most likely value, or do you sample one value, condition on the known values? So if you scroll down, so you see, so you have possible methods. This is the method of learn distribution. And then you have possible strategy, which is random sampling, marginal sampling, or mode finding.
Why is it mode finding? I mean, why isn't it just you're using the mode? I mean, in other words, the question is, what do you put in for the missing value? That's the basic question, right?
Yes.
Right, so the missing value is going to be filled in with something.
Yeah. We don't know the modes. That's why it's an approximation. It's going to try to find the mode. And
I understand, but why isn't it called mode approximation? I mean, as opposed to, I mean, why isn't it called random sample, marginal sample, mode approximation or something? Because these are the things you fill in. Because
it's a strategy. That's something that we already discussed in synthesized missing values. So only marginal sampling is new. Synthesized missing values already have random sampling and mode finding.
Okay, all right, okay. So, but the name of this option, it bothers me that this is too similar. I mean, this is basically what to do with missing values.
Kind of, which, by the way, we already have a lot of these options, and that's a bit annoying, but
well, right.
There's missing behavior. But they're used in such different contexts, and for, that.
So what are those options?
I think if you scroll down in the C also, I put them. You can see missing behavior, missing data rules.
Okay.
That's a two thing. Missing data rules and missing behavior. Option for semantic import that have this. I mean, it's completely different.
What should be considered missing and what to replace it with? That's a good question. What should be considered missing?
So this is missing pattern. We have missing pattern that solves that. Basically explain what should be.
Okay, all right, fine. So if it's 999 is the way you represent missing data,
yes,
then that can be used in missing value pattern.
Mm-hmm. And as there's missing behavior right after missing data rules.
Yes.
Which I forgot what it does, but it's pretty different as well. Yeah, option for query.
No, this is a mess.
Yeah.
So these all need to be brought together. So, I mean, missing behavior. Well, whatever happens, this is going to be an experimental thing, because we're not ready for this. I mean, we've got many different functions which have to deal with missing data, from things like around to things like semantic import to things, all kinds of things there.
Yeah.
And what this is doing is saying one of the possible strategies is you make it up, right? You make up data. And that possible strategy could be used in other places as well, right? There's no reason why in that dataset query business, it's a little bit scary. And I hate to think people would use that for some, but that's a standard statistical method of, you just make up extra data. Am I making sense?
Mm-hmm.
And there's no reason why we shouldn't support that. In fact, using these exact same methods and functions.
Did you also look into missing data method? That's another one that we have.
No.
I believe only used in time series and co.
Okay, so what a total mess. Okay, so look, let's do the following. Let's get a separate meeting for all of these missing functions. Okay, we inventory all of them, get everybody who's involved with all of them, and let's try and grind through what we do with them.
Oh, that is very,
What's that?
Yeah, this one is, I missed that one. It's pretty similar.
Right. So missing data method seems like a good thing to try to use for. I mean, this is a total mess. Missing data rules is the same thing as missing value pattern, I think. What to replace it with? Yeah, I mean, guys, we need to have a separate meeting.
Can we put this in LCC? Devin is here, maybe.
Yeah. The sense.
Okay, but then it's going to take over an LCC meeting. This will be a whole meeting and
be a separate.
All right, but for your purposes here, I don't understand why you can't use missing data method for this.
Yes, it will be. Yes, let's see.
The missing data methods, the methods seem to rely on the fact that it is a sequence. So all the methods are related to interpolation.
Well, what is the method? He doesn't even say what the methods are here. Where are the methods here?
No, I think you just can scroll down to example.
No, that's not good enough. I mean, so this documentation is clearly inadequate, right? Because if it doesn't say at the top, it effectively isn't here.
It's in options.
Okay, that's not good enough. That's not what we do.
But if this is a generic,
that is what we have been doing.
Yeah,
but
if it's a generic option, why not? If it can be used.
No, I understand that, but Roger is saying we don't have to document what the possible values for name are, and he's wrong about that. Right? It's not good enough to document them in the examples.
Yeah, but we have many cases, okay? This is where you are wrong, where you cannot document it globally because we don't have an object-oriented document system.
No, I understand that.
Okay,
I understand.
That means that there needs to be method-specific settings for individual functions. It cannot be for the overall
but it
thing.
shouldn't be. Okay, then we should have a separate discussion about this, because I think we're dealing with that primarily by these ways of having separate documentation pages for named objects like this. But that's a separate discussion, which should have been in the monthly documentation meeting, because I think this is, if that's really the issue, then let's break off yet a separate meeting for that. Okay, about documenting things where the possible names, the possible values for an option are different for different functions, right? That's the issue you're describing.
Yes.
Right. So let's break off a separate discussion about that.
Okay.
What we should do with that.
Yep.
Right. However, for this,
Yeah, one thing I liked is that it's really related to synthesized missing values.
I don't care. I mean, we've got like 8 different options.
Yeah, no, I agree. It's sometimes it's hard to package all that together as well. Huh?
Look, if you need it for this version, make an experimental function. We will clean it up later.
All right.
I would just call it missing value synthesis method.
It's but then inside you have method, strategy.
All right. Okay. All right. Missing value synthesis then. But let's make sure,
experimental, and we'll join all that. Yeah, I agree.
Right. It looks like we've got 5 or 6 functions which are all circling around the same question of handling missing data, which we know is an issue because it's also an issue for the statistics functions and so on, right?
Yeah, definitely. That will require some good design, but I think the results will be good.
Right.
Some hard design, but then the result might be good.
Okay, so P. Winkler is saying gradient boosted trees, random forest gives wrong results for even the same point when doing batch predictions. See red -2 number 945. So Devin, that's something for you to go chase down.
Sure.
Ethan is complaining that synthesized missing values doesn't work on images bigger than thumbnails. Etienne or anybody else?
Yeah, and that's a feature extraction issue. I mean, learn the distribution of images, and learning the distribution of images is something that is super hard. And so we need to do some transfer learning so it works on reasonable small amount of images. And we haven't nailed it yet. Like that's a hard problem. That's actually a hard research problem, how to do efficient transfer learning for learning generative model images. It's we had one idea. There was one intern working on this specific problem, but it didn't work out. It was too hard.
Okay.
The experiments were too difficult to carry.
Okay.
So I don't think we'll have a solution anytime soon.
Ethan is commenting, yesterday he trained a GPT-style network to take strings, images, categorically and generate text summaries, which we don't seem to be able to do yet. I don't know. I don't know what's involved in doing that.
So that's massive models trained on even more massive amount of data. And we eventually could have, it will not be in the repository. This cannot fit. People cannot download such things.
How do they get them?
They cannot run it. I mean, they run it through an API. Like GPT-3, no one else than OpenAI has GPT-3. They have an API that you can, access. It's probably used, I don't know how many GPUs just to run the model.
Well, presumably Microsoft has one in Azure too.
Exactly. Maybe there's one in Azure, exactly. And,
and they probably, sent it on a, on a hard disk or something.
Right.
So, I mean, if that's the future of, we'll do feature extraction and these sort of things, through something hosted in our cloud. But we have GPT-2 on the repository that you can use already.
How big are these big models? How big are the ones that are just sitting on centralized clouds?
I'm gonna check.
I mean, that's certainly an interesting scenario that I'm not sure. It's an interesting scenario.
So 175 billions of parameters.
Okay, but that's a few hundred gigabytes.
Billions. It's 700 gigabytes.
That sounds about right.
Yeah.
I mean, if they're doubles,
Yeah. Reaching the terabyte model, but to run.
Okay, Ethan is commenting you can download GPT-2 Medium and run it on a 16 gigabyte GPU. Do we have GPT-2?
We have GPT-2. We have GPT-2. I'm not sure if you have all the version. You can check in the repository.
Okay.
GPT-2 transformer trained on web text data.
And Ethan is commenting on new architectural pieces like Transgan, Assemble ResNet. Okay, these are not ones I've yet heard of. But I do think that sort of strategy-wise, this is an interesting question because, is the future, so two things seem to be happening, smaller networks and larger networks. That's my impression, at least. Am I right? Am I wrong?
I mean, I don't know if small network is happening. For images, it doesn't increase so much the size of the network. Small networks still do a good job. For text, they're getting absolutely massive.
Okay, but hold on, because my understanding is like our facial feature recognizer went down in size dramatically. Am I right?
Well, yes, I retrained with a much newer architecture that was optimized for size.
Yeah,
but is not always the case. I was trying to find actually if give me a second, the new family of detector by Google, the efficient det. They scale not just the input size of the image, but they scale the whole architecture across a line. So they increase the depth, they increase the number of filters, they increase everything. Of course, the last one, it takes like 10 seconds on my laptop, while the first one is half a second. And this because it has a lot more parameters.
Right, but so I'm just trying to understand the strategic future of these things, right? Is it going to be the case? So that's a possible model where you say, I mean, it's like doing, finite elements or something, or doing any of these things. You can say, well, I'm just going to use more data points, and then it'll take longer and be bigger, right? So my question is that the future of these kinds of things, that you can just say, I'm going to, for this problem and for this set of computer resources, I have these, I'm going to use this kind of network, and then maybe I'm going to use the bigger network, the more finite elements or whatever, in a case where I want higher fidelity or I'm prepared to spend more computer time. Is that the future of this area, or what?
I think that we haven't reached the end in terms of performance improvements for size.
Well, I understand that, but the question, okay, look, what's being said is,
but there's a shitload of applications that don't need any of this big stuff at all. If for signal processing,
of course,
for image.
I know. So there's a frontier that's using this big stuff, just like there's going to be a frontier for solving PDEs or any of these other things where you're running big codes that that use lots of memory and lots of processing time. So I'm trying to understand in this space, is it the case that in that case, basically there are certain kinds of PDE problems that are basically inaccessible unless you have the fancy supercomputer, but many are not. And so my question here is, what's the story with these kinds of systems?
It might be the case, although that there's a lot of efforts which is successful for image to reduce the network. That's why that didn't grow that big. So maybe it's going to happen with text as well. Then there's new hardware that might be more adapted to these networks. But
that's a different thing. That's the same thing that's happened with linear algebra and all these kinds of things, and that's what brought us GPUs in the first place. Okay. The issue is you're saying for images the networks are not getting much bigger. Is that the statement I'm understanding?
Yeah, they manage. They get bigger, but not like not.
There is a factor of 10. I just checked. Like between the smallest models and the largest model is a bit more than 10. Like let's say 30. But the push is like on one side you want networks that are extremely small as NEPI because you want to use them on phones, for example.
Devices, yeah.
Image network, or now basically all the photography part of the phone is a trade-off between taking a lot of pictures and running neural networks on them to optimize low light condition, focus. Like you don't want to rely on the camera equipment too much because it's expensive, and it's now those networks are extremely fast and they're also very, very small. Then you have those bigger networks that are.
The sad thing is one day, if a phone camera sees anything unexpected, it'll be like the blind spot for humans, where it'll just fill it in with random stuff.
I'm very worried that a car is just gonna crash into people at a carnival parade because it's not trained on that. But let's hope not.
Right. But the funny thing is that, like with our visual system, right, our blind spot where the optic nerve connects, we just fill in random things from neighboring parts of our visual field, and no doubt cameras are doing, or probably already doing, the same thing. If you have a spot of dust on the lens, it might just fill in a random image that from the context. But now talk about text for a second. My impression there is the models are getting really huge.
Yeah.
But do we understand why? And do we understand whether that's going to continue? Clearly the corpus, the corpora, there is a bound on the size of the corpora. Probably a much smaller bound. The amount of text that's been written in the world is much smaller than the number of pixels of images that have been taken. Right? And so my question, go ahead.
It carries more information, the text, though, I would say.
Okay.
I also think it's a problem of redundancy. Like you can alter a picture of a dog in very many ways.
Sure, right. The compression ratios for images are like factor of 100. The compression ratio of a text might be 50%.
It can be even more. If you know the data set, you can compress. How big are those image feature vectors? Maybe 1,000 elements, and that can work for if you have a single object in the image, can work for an image which is 1,000 by 1,000.
Right. Well, that's why people were trying to make up meaning vectors for text, which hasn't worked all that well. Right. Turns out the set of things people want to say, it's not surprising. There are many more. Sentences are combinatorial, whereas nouns, the number of nouns is a fixed number, like 5,000 in English or something. Okay, so there's questions here for about convolutional autoencoders for image feature extraction. Is that something that we have?
Actually, no. Amir did for sequence, like recurrent autoencoder. I don't think it did convolution.
Okay, so Ethan is complaining that training object detectors, we are working on training object detectors. That's something that is coming, and it's going to be very nice. Simple high-resolution GAN. I'm not so sure about that. can do that, but it's a little bit of a mess, and it's always a bit of a mess, isn't it?
To train GANs?
Yes.
Yeah, it's harder than regular networks, that's for sure.
Okay, let's just, I'm running into my next meeting here, but let's keep going for a little while here.
So since it's similar topic, yeah, recalibration function, you could look at this documentation page. And this is something we already discussed some time ago. So I think design-wise, we are in sync. I mean, we agreed. And
yes, I remember this issue. Yeah.
Yeah. So ideas for both classify and predict, you can put a function or specify if you want.
I remember, yeah. I mean, this is a bit of a complicated concept, but I think we managed to grind it to the point where it's somewhat usable.
Yeah, yeah.
Okay, let's go take a quick look through the rest of this. Okay, neural net supporting video in the net encoder. So is that something that's now done?
No, it's ongoing. We're planning to have it in 12.3.
Okay. And is it going to be, so then what will happen is, I mean, how big are the things that come out of a video? So let's say I have a minute of video. What do I expect to be the result of the net encoder?
It depends on how you constructed the net encoder and what parameters you're passing it. It could either be all of the frames, or it could be a sequence of a set number of frames. For example, 3 frames.
But it's not something that gives the overall flow with the frames. I mean, it is a frame by frame story.
No, this is a pretty dumb extractor in the sense that it just extracts frames and passes them to the neural network, and then the neural network will eventually do whatever complicated.
But so there's nothing that is the analog. I mean, there's nothing that's using the basically space-time structure of the thing. It's just using
just the fact that it is a sequence of frames. Then the network will be in charge of interpreting that as.
And there are no net encoders that go across. I mean, like MP4 or something would use the temporal dimension in its encoding of things, in its compression, right? It's using the fact that the frames don't differ very much. But you're saying that for neural nets, there isn't a way of doing net encoding that can similarly take advantage of the fact that frames don't differ much?
I am not aware of any. The net encoders for video that we've looked at all treat the input as sequences of images.
Okay,
well,
so
that
Ethan is
depends
commenting on NVIDIA's
on the architecture.
Pix HD. What is this? Code to Pix. I think, okay, so this is, I mean, that's an interesting question, is these networks that are being provided, let's say by NVIDIA, how do we plug into those things? Because, you know, one model of plugging into those things is through the neural net repository, but I don't know what the APIs for those networks are. And maybe there's an analog of service connections for some of these. I mean, there's a question right now. For some of these, for example, very big networks, okay, for some of these networks that are very GPU bound or very big and remote, what is the correct way for us to plug into them? In other words, things which for us, we must treat as black boxes. How should we, because right now what we're doing is we're providing mechanisms to bring the network into our ecosystem and do things with it and be able to, you know, seamlessly work with it. So the question is, what if the network is a black box of some kind, either remote or local? How can we deal with it?
You mean in terms of evaluation, or in more general question? What do we?
Well,
do?
I would say evaluation would be a good start. Yes.
I mean, if the black box, I mean, this is tied to the ONX evaluator, I guess. If it is not something we can.
I don't know, but I don't know whether we have a mechanism in the ONX, even in the current design of the ONX evaluator. I don't think we have a mechanism to deal with a black box thing with a certain API. See what I'm saying?
Maybe, but maybe not really, because it's, I mean, very open. If I interpret it correctly, it's a very, very open question. The API can be completely arbitrary.
I know. It's
I like,
don't know
I
if
throw
it
at you a library, figure out what to do with it without context.
No, that's impossible. Right, but the point is that we can curate for a certain fixed set of these things, we could curate, just as we do with service connections, we can curate the connectivity. Right. So the question is, I mean, this is what I'm trying to understand. You know, strategically, where is this field going? That is, you know, there are, okay, one thing is there are just neural nets that we can run in our evaluator, that we can run in our training framework, that are generically, let's say, ONNX compatible networks, right? That's one category. Another category is ones that are, you know, the petabyte network, the central, you know, text translation brain of the world that nobody's going to run locally. You know, that might be a direction that things are going. Another possibility is there are things that are deeply bound up with hardware.
Then isn't it an API?
Then it's an API, right? But then, and then another thing is the kind of, it's running in some, you know, funky special purpose hardware thing, and you have very little access to it other than just calling it somehow, like a system.
But then we have our connected device framework. If you want to sort of play in Wolfram language.
Yeah, I know.
It's not unreasonable.
Right, I'm asking, what do we, you know, right now we have the neural net repository that is a repository of local networks.
Yes.
Right? Just like the data repository is a repository of data that you can load into the system. Now we are in the process of changing that so that the data repository can provide the same metadata access, the same connectivity, but to data sets that can be completely remote or can be feeds, for example, right? So, you know, so in other words, you might have something which, you know, as far as the hooking it up within your program, it looks just like a standard resource data object, but it's actually a petabyte in size and it's remote.
I mean, if you want to do the same thing for a network, then it's we need really to think about that. I mean, I know that there are services offering that for translation, for example, but they maintain data centers in Iceland with the GPUs.
Yeah, but some of that is a bit overstated. But yes,
I mean, yes, this is what they claim at least.
Yes, it's rather overstated. But I mean, you know, for example, you know, it used to be the case that if you wanted to do voice to text, it always had to be on a central server that people said was mysteriously large. But it turns out that's just not really correct, right?
Oh, okay, but I mean, it's still a thing that we want to.
Well, it might be a thing. I mean, that's
that we need
right,
to.
But I mean, it's just like we have had a service connection for text translation. That's how it's worked. Text translation is a remote API right now for us, but it's about to be hopefully not a remote API, right? Or you're going to be able to pick something where it can be done locally, right?
Yep.
Right. So I mean, the point that I'm making is strategically, there's this question of, is it going to networks which are one of three possibilities? You know, only available on centralized cloud servers, ours, other people's, whatever. Only, I mean, just like, you know, we don't, our whole entity framework and knowledge base, that's not locally available. It's way too big, right? We cache pieces of it locally, but we don't expect the whole thing, and we expect people are going to use only some tiny corner of it. But, you know, with neural nets, it's a little different because right now, in the way neural nets are used right now, it's like, it's not the case that if you have a translation network and you're only talking about, you know, I don't know, the, you know, the feeding habits of the armadillo or something, that you only need to download a little piece of the network that's about, you know, words related to armadillos, right? That's not the way it works right now. Whereas in our knowledge base and entity framework, if you're only dealing with, you know, properties of volcanoes in Iceland, then you can get away with just caching properties of volcanoes in Iceland without, you know, caching things about the seismic properties of, you know, the such and such plate or something. Does that make sense? I mean, so in other words, there isn't the same kind of local, you know, partial caching thing. It's either you get the whole network or you get none of it. And so I guess the other possibility is that there are networks that are deeply tied to hardware, at least at the evaluation level, and that require essentially library type access, but are local. Am I getting all the cases, or are there other cases?
I mean, it seems reasonable. That might be more. I'm on top
right,
of
but
my
I mean, this is
mind.
what we have to think about, because if we're going to make a strategy, right, like for text translation, right, we know that the strategy is basically going to be, you can use the remote service if you want to, but you can also use, or you can, I mean, look, what we do with entities, let me remind you, is the first time you make a query, it's done remotely.
What's your goal that you're making a strategy for?
How we support things to do with neural nets to make them as useful as possible. Right, and so we don't get, a situation where people are asking us, but what about this network? What about that network? And we say we don't have a way to deal with that.
Well, why don't we ask? Don't we have like 50 people on here that come from all walks of life? What are some modes that we don't support that we should support?
Sure. If people want to make comments, that would be terrific. But in any case, I mean, we do have some specific comments here, and what I'm saying is, with text translation, just to recap, and I think this is an issue here. What we're saying is we're going to have text translation can operate in several modes. One mode is you do an initial text translation, and you don't want to download 5 gigabytes for this initial text translation by default, I would assume. Right, just like for looking up the height of such and such a volcano, you don't want to download hundreds of gigabytes of geographic data just for that one query.
I think it depends, Stephen. I mean, it's like if you have it running on a smartphone to improve your picture taking, as Julia pointed out, you want a fairly...
I'm well aware. So Roger,
okay.
This problem is one that we have worked on in detail for the knowledge base and entity stuff over the last several years.
Right.
And we have a pretty reasonable solution there. Mm-hmm. That may not be perfect, but it is a mixture of initial remote queries followed by background caching, followed by larger scale local querying. Right?
Oh, is that what you, as at the back of your mind, a sort of a hierarchy or something?
Yes, that's what I'm talking about. Yes.
Okay, I see.
Right. Or something where
I don't think we have enough of the pieces.
Well, I don't think that's right. I mean, we do have the pieces. We just, for example, for text translation, we have exactly the setup.
Yeah, we have the 2 setups. Yes.
Right, but it's not just 2. It's not just 2, because there are multiple networks that you could use for text translation. There are different sizes, different fidelities, etc. Am I correct, guys?
Yes. Yes. Actually, Geoffrey is going to convert 2 type. One is smaller and faster, and yeah.
Right. So, I mean, what we've done with a bunch of functions is performance, goal, quality, or speed. Which
I was just going to go down that path. It's like,
right.
That sounds like that.
Right. So that's a perfectly reasonable thing to do. But, we've got this. That's why I'm trying to understand strategically, is it the case that networks, this is the question I'm asking. My impression is that there is some lines of research that are leading to bigger networks, including very big networks, and other lines that are saying, let's take this, let's optimize the architecture, let's make smaller networks, right?
Yes, I think that's correct.
So our challenge is to understand, what do we do in that situation? So, the smaller networks generically will be puttable in the neural net repository and downloadable. The bigger networks will trail into things where you can only access them through APIs. Okay, so the question is, how do we make a uniform interface to all of those possibilities? And that's what we're doing with the data repository for pure data. So it's something that seems to me we should probably use that as a model for the neural net case. Does that make sense?
Yeah, and maybe external net might play a role here. We had the idea of having like the ONNX runtime and supporting ONNX network without using our framework. Maybe, it could be the interface to use external networks that are remotely.
Right.
Remote.
Well, okay, fine. But I mean, the point here is, what is that interface? How is that defined? Like, for example, for service connections.
I mean, that could be an application function, like the one that we brought up here. It's like text translation. where we can switch between modes.
Of course.
And we can automate that with, if it could be performance goals, like when is it worth taking the hit? But so we have similar things elsewhere. We do just-in-time compilation.
No, of course. And we've done this. The place where we've most developed this is in the knowledge base area. This trade-off between remote and local is most developed in that area. Right? But the question is this something we need to build for neural nets? Because if you're going to tell me that, well, actually, these giant neural nets are just a transient phase, and in every neural net that's been developed, people eventually found a way to compress it, then that's a thing worth knowing.
So the story so far has been that. Only recently with this GPT, it got super big, and we don't know yet if this can be reduced. But
I mean, the thing that is complicated is this is interwoven with market forces.
Also,
right?
If I may interject, one scenario, sure, networks have been reduced greatly so that they fit in commercial GPUs, but there are so many machines that do not have a GPU that is accessible by our framework. So even
that's a temporary, that is hopefully a solvable, is a thing that the industry is going to solve for us, so to speak.
Hopefully.
Right. So, I don't think we should plan on that direction. The question really is, I mean, the thing that's complicated is there are clearly market forces that are weighted towards make the networks incredibly big so they can only be run by a cloud provider. Right? There are reasons that people, it's like there are plenty of things where they could actually be done locally, even various kinds of web search things like that, but that's not a commercially attractive thing for people. Right? So this could be the same thing. The dynamics here could be, yes, you could compress these networks, but nobody really wants to do that. It's like, somewhat cynically, why make a cheap drug when you can make an expensive one? But I don't know whether that's what's going to happen. Right? The other possibility is that, as you've said, and it's by my impression, that most forms of network, they get big and then they get small again. Unless there's a fundamental reason why that can't happen, and you've made an argument that that can't happen for text, but I'm skeptical about that argument. People comment on this? Okay, well, I guess we should wrap up here.
So, yeah. So I was looking at a paper that was whose goal was to reduce this big text model, and pretty successfully. So I mean, I think it's not impossible that they will manage to reduce the size of the network and still have good performance.
Right. Well, so a meta model could be people make big things, and then within 2 years they're small.
Right? That's been kind of the trend, it's all
right. Yeah. But so if that is the trend, right, then them supporting the set of people who will need to use it in its big phase is sort of the leading edge research crowd, and that requires a different kind of tooling than, if it's the case that it's going to be permanently big, so anybody who's going to use it, any consumer who's going to use it is going to have to use the big one, then that's one thing. But if it's going to be the case that within 2 years everything becomes small, then it's a different set of infrastructural needs. And it will be really useful for planning purposes for us to be able to understand that. Right? But look, I think the right thing to do is to allow the neural net repository to be a gateway in the same way that the data repository is becoming a gateway that can access larger scale assets that are not going to be downloaded.
Yeah, that makes sense.
And then it's a transparent thing. Obviously, there will be performance issues. You can make a choice, just like you can with entities. You can either, it's an interesting question whether, I don't think we use performance goal explicitly with like entity value. We probably could. I mean, it's a different type of performance goal. It's, do you want to pay the price initially of a big download and then everything will be fast? Or do you want to have the initial download? I mean, we have chosen that automatically for users because it seems like that's the thing you always want. Okay. So let's just talk about a couple of more of these things, and then we need to wrap up. Text cases. So this is now based on our training loop between NLU and NLP. Is that correct, Jerome?
I can answer for Jerome. Yes, basically they are doing good work. They're going to have data for every entity and enough tag for Jerome to train the new version.
So wait a minute. So this is all entity types supported by interpreter.
Yes.
Is that correct?
So the short story is that Jerome in the past did a huge data set using Wikipedia link, the Wolfram Alpha interpreter, and a bunch of other things. But the problem is that it was some entity had a lot of tags and some had very little. So this is an effort to have a minimum number of tags for every entity.
Okay, but so wait a second. So these things like geocoordinates, street addresses, and so on, those are already taken care of, correct?
Look at text content.
Okay.
Text contents, and there should be a link to the guide of the text content entities.
By the way, if Devin could please report again in this prototype build that look at this absurd piece of garbage that we're seeing with this. Do you see this thing?
Yeah, that's
is going to work as well.
Just that it's jumpy.
Text contents both work.
What's that? Say that again.
List of text content type. Here you go.
Yeah, right.
So yeah, this is it. So there was supported, but many of them were really bad because we had a tiny data set for them. And now this is addressing this. So he's using some transfer learning and some bootstrapping, like he did quite some good research to figure out how to take maximum advantage of small data set. And he figured that with only 20 tag per entity, he could have pretty good result. So that's the task now. The curation team is doing 20 tag for every of this type. And
okay, so if I say, for example, if I say I want to pick out all airports.
Exactly. Like probably right now it doesn't work that well. I mean, airport, I don't know. Maybe airport works already good now, but if you take something even more, random, like
nuclear reactors.
Yeah, nuclear reactors probably we're very bad at it, but
I mean, to be good at it, I mean, I've no idea how they're named, but it could be, S22 or something. Could be a nuclear reactor. And to know that that's a nuclear reactor is largely a story of context.
Yes. That's why with only 20 examples per type, by learning the context, he was able to get like 90% or something like that of accuracy. And I mean, there's a precision and recall and so on, but
that's good. So in terms of documentation here, this documentation page presumably has to get updated. I mean, I don't know what all these.
Not that much, because the same type, it would just work better.
I see. Okay.
And I believe that after this version, text case doesn't have to be touched for a while. I think it's going to be, diminishing return from now on.
What about proper names?
I think yes. Okay, there was this, I forgot, person.
Right, I understand, but that's notable person. I'm asking for, I've got this list of, I've got this, this random thing. I want to know all the people who are mentioned in this news report, let's say.
Yeah, I think Jerome
look, I mean, to me,
or something,
okay, to me, there are tagging, there should be things in here. People, companies, organizations, products. Those are three types of things whose names can be kind of funky and which I guess can be deduced from context. And, those are pretty classic entity extraction types of things, but they're different from what we're doing here because here, these entity extractions are tied to ultimately our curated knowledge base, which is why we can get higher quality. But, the number of named pulsars in the world is some fixed set. The number of named products in the world is not a fixed set. Am I making sense?
Mm-hmm.
You know, is when I say, I don't know, pink chameleon, is that the name of a product, or is that a description of some, you know, animal that's, you know, some organism that's hanging out in wherever, you know, in some field of some kind of flowers or something? You know what I'm saying? So, you know, in other words, how do we tell if pink chameleon is a product name or whether it's something different? And what have we done on that?
Yeah.
What's the answer? Is Jerome here? Can he speak to that?
So Jerome, I think I should ping him. I think he got something. Otherwise, to answer the person, like check that there's given name, surname. I found them. There's person, given name,
no, but that's
surname,
not that, okay. But that's not good enough. Okay, that's not good enough. That's based on our curated knowledge base, right? So that's we do a good job of given names that we know about. Do you understand what I'm saying? That from the context of text, you can know about even given names that we don't know about. Right? In other words, if it says, you know, Ms. blah, 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 you know.
Given name and surname will work for the one we don't know about. I mean, it's not a fixed list.
Okay. All right.
It will work. Like, actually, you could try a Mr. and you put some random name. I'm pretty sure text cases should get it. I never tried it, so it might be wrong, but
let's try it.
I would bet that it works.
Okay. Mr. Coffee Bean had coffee with Ms.
Okay, you made it harder because coffee bean is also something else, but yeah.
I know. With Ms. You know, Alexis Smith. Okay, we'll make it easy there. Yeah. Okay. All right. Text so now what do I say here?
Text cases and either given name or surname.
But that's not good enough. I want complete person name. That's obvious. That's the thing that we're going to need. Right?
Well, I don't see that.
I know. I know. This is what I've been saying for ages. This is something we need.
What's happening?
Well, this is the prototype build, so I don't know whether that's is this in the prototype build? What's the story with this?
I mean, this was there before, so it's in the regular build.
Well, you can use the
Jerome has a new version. The new version is not yet deployed, huh? But I mean, it doesn't matter for surname.
Okay, but I'm telling you, this isn't what we want, right? I've been saying this for ages. We need something which is complete name. That's what people are going to need. And we've also been talking about for ages having a symbolic structure that represents, you know, a person with names and honorifics and all that kind of thing.
Yeah, I think.
And this is the place where we should start building that.
Originally, person was exactly what you described. So actually, okay, that's too bad Jerome is not there because he would answer.
But where is Jerome? He's listed as being here. So where is he?
I don't know. I think he must be lost somewhere. I pinged him. Yeah, person originally was exactly what you talked about. So I think, yeah.
Well, what happened to it?
Well,
what happened to it?
I don't want to say something wrong, but I think it's still.
Oh, that was good. I'm impressed. Good work. All right, so let's see how I say person here. A little weird. No, that was a little unconvincing.
Yeah, I think person is actually every person. It's not.
Okay, but that's just wrong in this case.
Yeah. But anyway, yeah.
Right, but so that's what we need. I mean, people, products, organizations. Yeah. Those are categories that we need, which go beyond, you know, I mean, these are things that we are uniquely in a position to do, and we're doing them, and that's great. But that doesn't get us off the hook for these other things.
Products, that would be the the one to focus then, because in company, no problem.
No. People names. I'm telling you, names are really important.
Of course, but,
right?
but you said product as well.
What's that?
You said product as well.
I did. I said people, products, organizations.
Yeah.
All three are, things people want. And they're complicated because their names can be very weird.
Yeah.
All three of those. I mean, I don't know whether we are off the hook for, stage names and stuff like this. Perhaps we are. Okay. By the way, somebody, Flippy, is commenting about Onyx. Yes, we have lots of support for Onyx, and in fact, we've contributed to Onyx, and it's we're very much on top of Onyx, although it's not a panacea, doesn't solve all problems. Let's see. Ethan is saying there's no entity recognition text cases. Yeah, of course there's entity recognition. That's what that's exactly what we're doing here. But some things are actual entities, right?
Yeah, I can put interpretable. I forgot the option.
Right, but I mean then that is actual entities which we can canonicalize. But if we are talking about a person's name, including all possible fictional people, that's not something for which we have entities. The whole idea there, which we've never built because we've never had a way to get this into the system, is to have a person symbolic wrapper that contains different components of name, et cetera, et cetera, et cetera. And that's something that was what we hoped we were going to build, out of things like text cases. So anyway, okay, all right. I think we're very much out of time here. So let's see. Anything else we want to talk about here? Onyx import export.
Yeah, just some updates. I don't think there's too much to talk. Remote training. Very cool stuff that Timothy and Giulio are doing, which is, I mean, Giulio can speak about it, right? It's related to the progress monitor harmonization and something to make it work with remote process. And yeah, do you want to say something, Giulio?
Yeah, we are basically trying. I mean, the remote process part is more Timothy. I'm working with Jesse, and we are experimenting solutions to basically have every function that uses the new progress framework be able to report to the client. So you can basically recreate the same progress indicator that you see when you call the function locally. You should be able to recreate it when you call it from the remote batch submission.
But wait a minute, in remote batch submit, I mean, a GUI is not, I mean, you can't have a GUI because the thing is running as a batch job.
It's true, but you have a batch object, and you then can query it, and you can say,
I see.
the dynamic progress of this
Wow,
job.
that's pretty space age. I mean,
but that
I didn't want to mention it because we have ideas. We are implementing the ideas, but I think they're sound.
But
right, but so in other words, you can get a snapshot update. You can say, now get me an update, and perhaps you can run it as a dynamic where it's pinging.
It's a dynamic. It's
exactly.
I mean, Jesse has already something which is, I think it's called dynamic status, and that's telling you, like how many operations are done. Like I think if you run it on Amazon, like what is working, what is already done, and we want to do something similar to the progress. So when you say, give me the dynamic progress, that's prints a dynamic cell that we are in charge of updating. I mean, it will not be as snappy as the local one, of course, because it's a network operation. But maybe, I don't know, you get a refresh, like a bar that ticks every few seconds. That's still better than nothing.
Sure. But I mean, I'm sure this is modeled after what happens with remote batch map submit, which has a pretty nice mechanism.
Exactly. Oh yeah, I was talking about that. Yeah, we want to do something like that for the progress, the progress bar and the grids and everything. So in principle, if we manage to pull this off, you will be able to see the same training grid that you see for NetTrain locally, just with a bit slower tick of updating.
Yeah, that's really nice. Yeah, that's really nice. That's good.
So that's the goal, let's say.
Yeah, and this, I think, is a super important project because many have been asked, how can we train remotely? And we say, well, you can use a script, but I'm not very happy because I say, well, I have this all nice front end, and if I have to do everything with command line, what's the point? Whereas with all these tools, it's going to be not exactly like training locally, but very close, similar experience.
Okay, so there's a number of comments on our text chat. Lou is asking about using text cases and giving feedback about it, how to contact the team. The best way to do that is to join the beta program, because there's a whole mechanism there for interacting with upcoming developments. And I'm sorry, the poor CEO doesn't know how you do that, but I'm sure there's I'm sure it's not too hard, and maybe somebody can put that on a chat how to do that. Ethan is commenting, wouldn't persons be like an abstract entity class? Yes, in principle, except we don't really have a notion of an abstract entity. Well, we have entity classes that are constructed for things like database schemas. Kind of. I think it would be more like molecule. Because I think that a person is, you can think about it like there's different conformations of a person or something. It's like the same person, but they can have different names, and they can have, different honorifics, and they can have all kinds of different things. I think it's a different kind of concept. Ethan is commenting on wanting remote net train, and that batch submit is too expensive. I mean, I think that's a question of that's for cloud providers. I mean, so the basic point is, if I'm understanding correctly, is you want to run it on your own local machines. I don't know. Okay, so why is that difficult? I mean, can't you just use remote evaluate of NetTrain to do that on your local remote machines, so to speak? Does anybody know? Is there a problem with that? I mean, so there's a question then of, if you say remote evaluate of NetTrain, do you get the progress monitoring coming back to your local system and so on?
Yeah, currently not.
No.
Yeah.
Right. So that's a question, is whether remote evaluate can pass back progress monitoring. That seems like a more general remote evaluate framework question.
But this is why we want to tackle this progress thing for the remote batch submit. We want to tackle at the progress framework level. So I guess this is another project framework. Progress framework project. One thing I don't know, I've actually never used remote evaluate, if it does return something that you can query, or you just wait.
No, it's just remote evaluate is a blocking thing. There's another version, remote submit, that I think is ready, which does returns a task object.
Okay.
Okay.
This will need design then. Yeah.
Right. So Ethan is commenting on the whole, the flow of money for batch submit stuff. Yes, we know it is not as clean as it might be. That is more of a business problem, which is getting worked on very actively. I mean, it's a multi-company business issue, and yes, hopefully this will be solved in a good way. Unfortunately, it's not something solely under our control, so to speak. Yeah, I mean, that's just. I think actually, well, maybe it's not yet announced what exactly. One part of that I know is coming in the fairly near future. I think it's technically basically ready. Okay, well, we should wrap this up. It looks like we still have more things to go over, and we have several things to come back to here.
Yeah, there was not. I mean, this little thing, new activation function, link to a new library. Otherwise, I don't think there's big design. Not much design left, huh? Besides, missing value synthesis.
Yeah. So I mean, this comment from Ethan about remote batch submit and license entitlements and so on. Somebody should pass this on to Jesse just to make sure that the things we're planning will actually satisfy what is being talked about here.
Okay, I can do that. Jesse Friedman.
Yes.
Okay.
The Perkinj is asking about TPU support. I assume that that's available through the mechanisms we have. I mean, MXNet supports that stuff, yes?
TPU, I think it's just for TensorFlow.
I see.
So
okay, so you have to output it as Onyx and hope that the things actually are consistent, which they're probably not.
It's for training, so Onyx wouldn't be so useful here.
What about for the net architecture?
So, I mean, to train a net, since we don't have TensorFlow, I don't think you can use TPU.
Fair enough.
That's basically it, huh?
I mean, that's a trade name of a particular species of thing. All right. Okay. We should wrap up here. Thanks, everybody. And thanks to folks on the live stream.